This is the EdExcel A-Level Maths Paper 3 covering the Mechanics module, and this is from the 2024 series. Question number 1. Figure 1 shows a particle P of mass 0.5 kilograms at rest on a rough horizontal plane. Part A. Find the magnitude of the normal reaction of the plane on P. Well, to begin with, we have the weight of the particle given as 0.5 g. We have the normal reaction of the plane on P, which is shown here by R. And as we are in equilibrium, and if we resolve vertically, we would have R equals 0.5 g, which is equal to 4.9 newtons. The coefficient of friction between P and the plane is 2/7. A horizontal force of magnitude x newtons is applied to P. Given that P is now in limiting equilibrium, part B, find the value of x. Here is the horizontal forward force, x newtons. Opposing this, we have a frictional force, F. To begin with, we can find F max. F max is equal to mu, the coefficient of friction, multiplied by the normal reaction, R. Knowing what R is, that's 4.9, and knowing that the coefficient of friction between P and the plane is 2/7, we have 2/7 multiplied by 4.9, which is equal to 1.4. So F max is equal to 1.4 newtons, and therefore, resolving horizontally, we would have x equals F max. F max is 1.4 newtons, therefore x is equal to 1.4 newtons. Question number 2. Figure 2 shows a speed-time graph for a model of the motion of an athlete running a 200-meter race in 24 seconds. The athlete starts from rest at time t equals 0 and accelerates at a constant rate, reaching a speed of 10 meters per second at t equals 4, then moves at a constant speed of 10 meters per second from t equals 4 to t equals 18, then decelerates at a constant rate from t equals 18 to t equals 24, crossing the finishing line with speed u meters per second. Using the model, part A, find the acceleration of the athlete during the first 4 seconds of the race, stating the units of your answer. In the first 4 seconds, we are travelling with constant speed up until we reach 10 meters per second, and the acceleration will be given by the gradient of this line. Therefore, for part A, the acceleration A, that is equal to 10 divided by 4, which is equal to 2.5, so the acceleration is 2.5 meters per second squared. Part B. Find the distance covered by the athlete during the first 18 seconds of the race. To find the distance covered in the first 18 seconds of the race, we are required to find the area under the curve between 0 and 18 seconds, and that is split up into 2 parts. We've got a triangle in the first 4 seconds, and then we have a rectangle in the next 14 seconds. Hence, the distance S will equal 1/2 times 10 times 4, which is the triangle in the first 4 seconds, plus 18 subtract 4 multiplied by 10, which is the rectangle in the next 14 seconds. And working this out, we end up with 160 meters. Part C. Find the value of U. Well, we know that the total distance covered in 24 seconds is 200 meters, meaning the area under the graph is all equal to 200. We know the area from 0 to 18 is 160. We worked that out in part B. Here we have a trapezium. Therefore, we can form an equation to find the value of U. So, for part C, we have 160, which is the distance covered in the first 18 seconds, plus 1/2 times 10 plus U times by 6. That is the distance covered in the final 6 seconds. And all of this is equal to 200. So let's simplify where we can. Well, 1/2 times 6 is equal to 3, and we are multiplying this by 10 plus U. So we have 3 multiplied by 10 plus U, and 200 subtract 160 is 40, so 3 multiplied by 10 plus U is equal to 40. And if we solve for U, you will find U to equal 10 over 3. Question number 3. A particle P of mass m is held at rest at a point on a rough inclined plane as shown in figure 3. It is given that the plane is inclined to the horizontal at an angle alpha, where tan alpha equals 5 over 12. The coefficient of friction between P and the plane is mu, where mu is less than 5 over 12. The particle P is released from rest and slides down the plane. Air resistance is modelled as being negligible. Before we do anything else, let us show all the forces. We have the reaction force R, we have the weight mg, it's inclined at an angle alpha, and if the particle slides down the plane, we have friction opposing it. Here is the frictional force F. If we know that tan alpha is equal to 5 over 12, constructing a right-angled triangle, the hypotenuse will equal 13, and that is using Pythagoras, and from this we can conclude sin alpha is equal to 5 over 13 and cos alpha is equal to 12 over 13. Using the model, part A, find in terms of m and g the magnitude of the normal reaction of the plane on P. Here, we need to resolve perpendicular to the plane. Hence, for part A, R will equal mg multiplied by cos alpha. We know that cos alpha is equal to 12 over 13, so we multiply mg by 12 over 13, leaving us with R equaling 12 mg over 13. Part B. Show that as p slides down the plane, the acceleration of p down the plane is 1 over 13 g multiplied by 5 subtract 12 mu. Now in this question, eventually we will have to use Newton's second law, but what we can do is find out what this frictional force is equal to in terms of mu. So for part B, the frictional force F, that is equal to mu multiplied by R. So we have mu multiplied by R, which we worked out in part A to be 12 mg over 13, and therefore the frictional force F is equal to 12 mu mg over 13. We can now resolve parallel to the plane and use Newton's second law. So using Newton's second law, we have mg multiplied by sine alpha subtract f. This is equal to the mass m multiplied by the acceleration a. Now we know that sine alpha is equal to 5 over 13, so we have mg multiplied by 5 over 13 subtract f, which we know is 12 mu mg over 13, and this is equal to ma. Now the m's cancel on the left and the right hand side, leaving us with 5g over 13 subtract 12 mu g over 13 on the left hand side, and on the right hand side we have a. And if I solve for a by factoring out a 1 over 13g, a is equal to 1 over 13g multiplied by 5 subtract 12 mu meters per second squared. Part C. State what would happen to p if it is released from rest but mu is greater than or equal to 5 over 12. Well, for part C, if mu is greater than or equal to 5 over 12, then the particle will not move, as a would be less than or equal to 0. Question number 4. At time t seconds, where t is greater than or equal to 1, the position vector of a particle p is r meters, where r equals ct to the 1/2 I subtract 3 over 8 t squared j, and c is a constant. When t equals 4, the bearing of p from O is 135 degrees. Part A. Show that c equals 3. For part A, let's substitute in t equals 4 into this equation for r. So we have r equals c multiplied by 4 to the power of 1/2, and this is in the I direction, and then we subtract 3 over 8 multiplied by 4 squared, this is in the j direction, and working this out we end up with 2c I subtract 6j. We know that when t is equal to 4, the bearing of p from O is 135 degrees. So let's represent all of this in a diagram, such as the one we see here. We've got this 135 degrees, meaning if here we extend the north line, this angle is 45 degrees, and we've got the vector 2c in the I direction, and in the j direction -6. Of course we are going from O to P, so we go down by 6 and across by 2c. Now what we can state then using this diagram is -6 over 2c is equal to -1, and the reason for that is the gradient of this line OP is -1, and we have an isosceles triangle. We've got 45 degrees, this will also be 45 degrees, and then we've got the 90 degrees. So negative 6 over 2c is equal to negative 1 because the gradient is negative 1 of this line segment, and we also have an isosceles triangle. Therefore, we have 6 equals 2c, and solving for c, you will find c to equal 3, which is what we wanted to show. Part B. Find the speed of p when t equals 4. Well, to begin with, we know that r is equal to 3t to the 1/2 I subtract 3 over 8t squared j. All I've done over here is I've replaced the c with 3. Now we need to find the speed, so for us to do that we need to find the velocity vector. The velocity vector v, that's equal to dr over dt. So if I differentiate r, well, in the I direction we have 3 over 2t to the negative 1/2, and in the j direction we have negative 3/4 t. Now, what we need to do is find the speed when t equals 4. So when t equals 4, v is equal to 3 over 2 multiplied by 4 to the negative 1/2 I subtract 3 over 4 multiplied by 4j, which would simplify to 3 over 4i subtract 3j meters per second. This is a vector. We need to find the speed, which is the magnitude of v. So the speed will equal the square root of 3/4 squared plus negative 3 squared. So working this out, we have 0.75 squared plus 9 all square rooted, which is equal to 3.09 to 3 significant figures. So the speed is equal to 3.09 meters per second. When t equals t, p is accelerating in the direction of negative I subtract 27j. Part C. Find the value of t. To begin with, we need to find the acceleration vector. The acceleration vector is given by dv over dt, so we are required to differentiate this result. Hence, the acceleration is equal to negative 3/4 t to the negative 3 over 2 I subtract 3/4 j. We know when t equals t, p is accelerating in the direction of negative I subtract 27j. Hence, when t equals t, we have negative 3/4 over negative 3/4 t to the negative 3 over 2 equaling negative 27 over negative 1. And with this, we can find out what t is. Well, on the left hand side, the negative 3 over 4 over the negative 3 over 4 simplifies to 1. So we have 1 over t to the negative 3 over 2, which is t to the 3 over 2, and negative 27 divided by negative 1 is 27. So t to the 3 over 2 is equal to 27, meaning t is equal to 9. Question number 5. At time t equals 0, a small stone is projected with velocity 35 meters per second from a point O on horizontal ground. The stone is projected at an angle alpha to the horizontal, where tan alpha equals 3/4. In an initial model, the stone is modelled as a particle p moving freely under gravity. The stone hits the ground at the point A. Figure 4 shows the path of p from O to A. For the motion of p from O to A, At time t seconds, the horizontal distance of P from O is x meters. At time t seconds, the vertical distance of P above the ground is y meters. Before we do anything else, if we know that tan alpha is equal to 3/4, we can construct a right-angled triangle, such as the one we see here, and using Pythagoras, the hypotenuse is 5, from which we can conclude sine alpha is equal to 3/5 and cos alpha is equal to 4/5. Part A. Using the model, show that y equals 3/4 x subtract 1 over 160 x squared. For part A, we need to use the Suvat equations horizontally and vertically. Horizontally, s is equal to x, vertically, s is equal to y. Horizontally, u is equal to 35 cos alpha. Vertically, u is equal to 35 sine alpha. Horizontally, a is equal to 0. Vertically, a is equal to negative 9.8. And horizontally, t is equal to t. Vertically, t is equal to t. We are required to use the Suvat equation s equals ut plus 1/2 at squared both horizontally and vertically. So, if we use s equals ut plus 1/2 at squared, let's first of all consider the horizontal motion. We have x equals 35 cos alpha multiplied by t plus 1/2 multiplied by 0 multiplied by t squared. And we know that cos alpha is equal to 4/5. So we have x equals 35 multiplied by 4/5 multiplied by t plus 1/2 times 0 times t squared. And this simplifies to x equals 28t. And I will rearrange this to say that t is equal to x over 28. I will call this equation 1. Let's now resolve vertically. Vertically, we have y equals 35 sine alpha multiplied by t plus 1/2 multiplied by negative 9.8 multiplied by t squared. And we know that sine alpha is 3/5. So we have y equals 35 multiplied by 3/5 multiplied by t plus 1/2 times negative 9.8 times t squared. And this simplifies to y equals 21t subtract 4.9 t squared. Let's call this equation 2. Now because in our show that we want y to be in terms of x, we can substitute in equation 1 into equation 2. And doing so, we have y equals 21 multiplied by x over 28 subtract 4.9 multiplied by x over 28 squared. And if we simplify this, we have y equals 3/4 x subtract 1 over 160 x squared, which is what we wanted to show. Part B. Use the answer to part A or otherwise to find the length OA. Essentially, we are solving a quadratic equation and we are finding this intersection point here with the effectively x-axis. Now, we've got y equals 3/4 x subtract 1 over 160 x squared. I'm going to factorize out an x. So we have y equals x multiplied by 3/4 subtract 1 over 160 x. And if I set this equal to 0, I can find the x coordinates. So I've got x multiplied by 3/4 subtract 1 over 160 x, and this is equal to 0. So either x is equal to 0 or 3/4 subtract 1 over 160x is equal to 0. And if I solve 3/4 subtract 1 over 160x equal to 0, you will find x to equal 120, meaning going from 0 to 120, OA will equal 120 meters. Using the model, the greatest height of the stone above the ground is found to be h meters. Part C. Use the answer to Part A or otherwise to find the value of h. For Part C, the greatest height occurs when x is equal to 60 meters, and that's by symmetry. So the greatest height, yh, that's equal to 3/4 multiplied by 60, subtract 1 over 160 times 60 squared, and it turns out this is 22.5 meters. The model is refined to include air resistance. Using this new model, the greatest height of the stone above the ground is found to be k meters. Part D, state which is greater, h or k, justifying your answer. For Part D, h is greater as air resistance would slow down the particle. Part E, state one limitation of this refined model. For Part E, the stone is still modelled as a particle, so that is a limitation. Question number 6. Figure 5 shows a uniform rod AB of mass m and length 2a. The rod has its end A on rough horizontal ground. The rod rests in equilibrium against a small, smooth fixed horizontal peg P. The point C on the rod, where AC is equal to 1.5a, is the point of contact between the rod and the peg. The rod is at an angle theta to the ground, where tan theta is equal to 4 over 3. The rod lies in a vertical plane perpendicular to the peg. The magnitude of the normal reaction of the peg on the rod at C is S. So let us demonstrate all of this on figure 5. We've got this rough horizontal ground. We've got the reaction force R at A. We've got the frictional force here. We've got the angle theta. We've got the weight of the rod, mg. And here is the angle theta. We've got the normal reaction S. Here we have the angle theta, and also here. If we know tan theta is equal to 4 over 3, constructing a right angle triangle, the hypotenuse is equal to 5, from which we can state sin theta is equal to 4 over 5 and cos theta is equal to 3 over 5. Part A, show that S is equal to 2 over 5 mg. Now for us to do this question, we need to take moments about A. The reason we take moments about A is because this will eliminate R and F. So we have clockwise equaling anti-clockwise. So taking moments about A, from here to here we've got a length of A. The force acting down is mg. So we have mg multiplied by the perpendicular distance, A cos theta, and that's equal to, well here, we have a length of 1.5 A, the perpendicular force is S, hence on the right hand side we have S multiplied by 1.5 A, and we know that cos theta is equal to 3/5, So we have mg times a times 3/5 equals s times 1.5a. And solving for s, you will find s to equal 2mg over 5. The coefficient of friction between the rod and the ground is mu. Given that the rod is in limiting equilibrium, part P, find the value of mu. Well, going back to our diagram, what we can do is resolve horizontally and vertically. If it's in equilibrium, resolving horizontally, we have F equaling S sine theta. Now, we know what S is, we worked that out in part A, that's 2mg over 5, and we multiply this by sine theta, which is 4 over 5, meaning F is equal to 8mg over 25. Let's now resolve vertically. Well, we have R going up, we also have a component of S going up, and going down we have mg. Hence, we have R plus S cos theta equals mg. We don't know what R is, but S we know is 2mg over 5, and cos theta we know is 3/5, and this is equal to mg. If I solve for R, you will find R to equal 19 mg over 25. Now, if I use F equals mu R to find out what mu is, F I know is 8 mg over 25, and this is equal to mu multiplied by R, which I've just worked out to be 19 mg over 25, meaning mu is equal to 8 over 19. As a decimal, 8 over 19 is equal to 0.421, etc.